So welcome back guys. Today simple topic galvanometer, ammeter and voltmeter means devices. So after this meter bridge potentiometer will study. So if you see galvanometer, ammeter, voltmeter all are the same pattern means galvanometer is changing into ammeter and voltmeter. So here I have given all the important points related to galvanometer, ammeter and voltmeter. So the galvanometer is used to measure the small amount of current like micrometers means deflections we will call them. So very small amounts in the circuit. And small voltage means galvanometer can be measured amperes as well as means current as well as voltage. The maximum current how much is passing through the galvanometer, that is called full scale reading. So this full scale reading has divisions. The full scale has divisions. For example, galvanometer reading is like this. So the deflections of galvanometer can be right hand side or left hand side, that depends on the direction of the current in the circuit. In electromagnetism we study that. So for example, this galvanometer has a range up to some numbers 0 to 200 or 0 to 100 you take. So this 0 to 100 deflections, suppose here this is a 10. So this 10 is divided into again 10. So now the small unit by number of means in the deflection, total number of deflections. So the least count, how much we can measure by using this least count is, how will tell means the small number of unit, small number, total unit is 100. But in this 1 unit is equal to 10 by the number of divisions. So 1 unit by number of divisions. So 1 unit is 100, 100 divided into 200 parts means 100 by 200. So that you know already in normal scale how we use 1 millimeter means 1 unit is 1 centimeter. It will be divided into 10 parts. So that is so like that. So here only 1, 2, 3, 4, 5 parts only are dividing. Therefore here number of divisions will become 5, that equal to 2 microamperes is the least count. Means by this device I can measure only 2 microamperes of current. The same way voltage also. So this is about symbol also in laboratories. So this is galvanometer deflections, and the galvanometer works on the electromagnetic induction principle. Means electromagnetic induction given by Faraday. That is when in between the magnet there is a current carrying coil. So the two magnetic fields are gives the non-uniform field, and this non-uniform field gives the force on coil. The coil rotates. That rotations are the deflections in the galvanometers. So that is working principle is electromagnetic induction. Here you can see EMI. So now coming into how galvanometer is converted into ammeter. So ammeter, we can say ammeter, voltmeter, modified galvanometers. That means galvanometer is changing into ammeter to measure the current. So I want means here I want I value of the current. So I want to measure by ammeter up to I value 5 milliamperes or 10 milliamperes. That is the range. That is called range. So this here I is equal to range of ammeter. So this value I want to measure by using that ammeter. So now the galvanometer is converting into ammeter of required value by shunting a resistance with S. Means shunting resistance means a resistance, new resistance, known resistance is adding to galvanometer. So galvanometer already have resistance G. So now when I require I current, so for this galvanometer which one I have already, so I am shunting with resistance. So this resistance is called resistance of a ammeter also I can tell. So now this device will become as a ammeter. So galvanometer shunted with one parallel resistance. Shunting means the adding the resistance in parallel. Remember this. In meter bridge also, in potentiometer also, this top will come. See now. So now to find out the current and resistance. So here we will follow the again Ohm's law. According to Ohm's law, V is equal to IR, that you know. So if you see here, the galvanometer and shunt resistance are parallel. Therefore, the current into resistance in the first branch is equal to I minus Ig into S. This is I is the required value of ammeter. So how much value of current ammeter has to measure, that is. So from this you will get the current Ig is equal to I into S by G plus S. G is the resistance of galvanometer, and here galvanometer resistance is means current is proportional to the reading of ammeter. Means ammeter reading you want to means the shunt resistance should be more. So the resistance of ammeter is Hg by S plus G. Means here S is the resistance connected parallel to the galvanometer resistance, galvanometer. So this is resistance of ammeter, and I is the required amount of current. So now if you see ammeter connected in series with all the appliances in our households, and shunting resistance is low, so overall parallel resistance will become more low. So we know already in parallel connection of resistors, the effective resistance is, for example, there are two resistors are there. S is less than G consider. So the effective resistance will be less than S. For example, this is 1 ohm and this is 1000 ohm. So now the effective resistance is less than 1 ohm. If it is 0.1 ohm, then effective resistance also less than 0.1 ohm. So how much lower the resistance, the range of ammeter will be more. The range of ammeter will be, if you want more amperes, milliamperes, means microamperes to milliamperes you want to change, means 1000 times you have to increase. So if you want to change into amperes, 10,000 times current you have to increase, then resistance should be the lower in the circuit. So that is. I hope you understand this. One model of the problems also I will give. So coming into voltmeter, the voltmeter is also a device, modified galvanometer, which is used to measure the voltage. And here, one point I forgot to tell, ammeter is connecting in series to measure the current in circuit. That means resistance should not affect in the circuit, because we are connecting in series ammeter to measure the current in appliances. So the total effective resistance should not vary by adding this ammeter in series. That's why the ideal ammeter have zero resistance. Remember, this point is very important. The same way voltmeter, the ideal voltmeter have more resistance, because we are measuring the voltage at any appliance by connecting the voltmeter in parallel. So when parallel you are connecting less resistance, the effective resistance as we discussed above, more or less will come, then current will be increased more. So that will not give exact value which is required. So what you have to do means, the current should not be divided in the, current dividing means voltage will vary. At each appliances voltage will vary. But in the parallel we know the voltage is constant, current will be divided. Current when you will divide, and we have a one theory, that is current to choose. I choose the path, like Fermat principle in light. Here I choose the path which you have least resistance. Least resistance means through that current can go. To that resistance, more amount of current will go. In series already, in parallel we discussed that the ratio of how current will be divided. The same way here also. So now how to measure voltage drop at this resistor. So we know in parallel connection voltage will be same in the all the branches. However, infinite branches also voltage is same. So now here the R value is more, the voltage value also more. The range of voltmeter is, you want more means here you have to consider the the known resistor, known value of resistor with the series galvanometer. Means the galvanometer already have some resistance. With that, the more resistance add means you will get more value. Range of the voltmeter will be more. Means you want to measure 10 volts means here something resistance. 5 volts means less than that. 15 volts means more than that. So that is because here the voltmeter reading V is equal to I into GR. Here I is equal to is not dividing through the voltmeter because it is parallel and it has infinite resistance. Voltmeter has infinite resistance, so it is not divided here because the current already I said current chooses the path which has least resistance. Maximum current will go through this one. That is why we are making the voltmeter has high resistance. That means infinite up to ideal voltmeter. So now this is the formula to find out the voltage. And R is more, adding series with galvanometer more resistance, voltage range also more. Now coming into question number 1. So here galvanometer resistance is given and current through it is given. So now you know V is equal to IC. So now S1 is the value of something which convert into an ammeter to 0 to I. So I is the required value or what we will call that is range of voltmeter. So I is the required current. So here outside. So now through the galvanometer Ig current is going means I minus Ig through the shunt resistance. So ammeter means shunting, we are shunting the resistance parallel to galvanometer. So now I minus Ig into S1 is equal to Ig into G. So here voltage same, parallel na there. So now I1 S1 is equal to Ig into G plus S1. By that S1 is equal to shunting resistance is equal to Ig into G resistance of the galvanometer by I minus Ig. Similarly here also same. Then S2 will get something other value. But here the means I require more value of ammeter. So here less resistance I have to add S2. So see here 2I minus G means this 2I value is more than this value. So more means the total value denominator will become less. That's why S2 will be more. Here S2 will be more than S1. It is very clear given. S1 and S2 S2 is more than S1. So now S1 by S2 is asking the question, the ratio of that. So I want required more current in ammeter. So the shunt should be less. Therefore S2 will be less will come. 2I minus G is more. This value is more. Then S2 will be less and S1 will be more. So here this point. So now another question. The voltmeter resistance has G ohms and range is V volts. So I want to increase the voltage range is NV. Then what I will do? So it is very simple. Initially it is IC voltage V and G ohms. V is equal to IC. So now NV I want. So I am adding some resistance series with G. Therefore I into G plus R. So by that R I can find out N minus 1 into G. So here if you see galvanometer has resistance 30 ohms and 2 millimeter ampere. This is the full scale reading. I want to convert into 3 amperes, milliampere, 3 amperes of ammeter and 0.2 volts of voltmeter ranges. 3 ampere ranges and 0.2 voltmeter ranges. So now in conversion of this one, so in conversion of galvanometer into ammeter, I have to shunt a resistance parallel, right? So this is G. So there is a shunting resistance like this. So here current is I minus Ig. So I is the range of current and Ig is the current through galvanometer. So that is already. So now the voltage here voltage and here voltage is same because this galvanometer resistance and shunt resistance is parallel. So voltage is same. Therefore voltage is find out first of all. Voltage means I into R according to Ohm's law. Now minus I minus this Ig value into S. So S is equal to, you will get 0. So now here this is 60 into 10 power minus 3, 0.06 will come. 3 minus 0.02, it will be 0.002, that is equal to 0.298. Substituting means you will get 0.2013 ohms. So this is the shunting resistance to get this many amperes, the required value of amperes. So now required voltage I want. So to convert this galvanometer, 30 ohms of resistance, galvanometer resistance, and 2 milliamperes, I want to change into voltmeter of required value 0.2. What I have to do for galvanometer, I have to add another resistance R. So this is asking how many ohms of resistance I want to add to get the galvanometer as 0.2 volts voltage. So here 0.2 voltage is equal to, here 0.2 means here also 0.2 voltage will come in parallel. So therefore 0.2 voltage is equal to the G. G means galvanometer resistance 30 plus R into current. Voltage is equal to I into R. R equal 30 plus R. 30. This is 30 and R. Series 30 plus R into current. So by solving that, we will get R equals 7. So this is about galvanometer converting into ammeter and voltmeter. So in the next video, V-stone bits, unbalanced V-stone bits. Already V-stone bits I have given. Unbalanced and potentiometer I have to explain. Yes, I'll give in the next video. Thank you all.